Okay. Good afternoon, all. I welcome you all for this today's session. And from previous session, we are discussing the second chapter from this plastic engineering subject, processing and welding of the plastics. In today's session, we are going to discuss the extrusion molding process. How we are going to use the extrusion molding process for the processing of the plastic materials, and one extra operation, that is calendaring process, that also I will try to complete in today's session only. And before starting this session, just I will take the review of previous session. In previous session, we have completed the introductory part of this processing and welding of the plastics. In this, we have discussed this syllabus in this chapter related to the processing and welding of the plastic. And we have discussed that what is the meaning of processing of plastic and what is the meaning of welding of the plastic. And we have gone through the names that particular processing methods we are going to discuss in that this chapter, and particular welding processes that we are going to discuss in this chapter. And only one method I think I have completed in previous session, that is the injection molding process. Okay, this injection molding process, we have completed this in the previous session only. And in this injection molding process, it is basically we are using it. I have highlighted this, whichever these four processes I have shown here. Generally, we are using these four processes for thermoplastic materials. Okay, and these compression, transfer, and rotational molding, generally we are using these processes for thermosetting plastic material. Okay, I will after finishing this first part, I will ask the reason behind it. So first I will complete it, then you have to tell me why we are using only these methods for thermoplastic material, why this injection molding cannot be used for processing of thermosetting material. Okay, very simple reason is there. Just you have to observe the processes. Okay, the first process, injection molding process. In this, we have discussed the basic principle, and its two types. Simply, we are collecting the raw material through this hopper in this cylinder or barrel. Then what we are doing, we are heating the material, that raw material, and whichever pasty raw material is there in that barrel, that we are pushing or pressing in the mold cavity. Okay, and here it will get the desired shape and size. And at the end, we are going to cool this mold and we are going to eject this component. Okay, got it? And depending on the means type of or method used for applying that pressure, it has two types. Suppose we have used the ram and motor arrangement, or we are using ram or with some hydraulic fluid, here you can see, and we are applying the pressure. Right side part, how it will be operated through the motor. Simultaneously it will work. We will provide some time and we will start it. Initially material will enter from this, then some heating time will be provided, and after sufficient heating time, that raw material is now in the paste form. Then we will start this, and simply it will push whichever material is stored in this barrel, it will push it through this wall into the mold cavity. Okay, initially we are not starting this part. We will wait for some time so that we will get the raw material in the pasty form. Okay, means you can say that it starts melting due to that heat, and then we are applying the pressure. Okay, and this pressure can be applied through this ram arrangement, or we can use the screw, rotating or reciprocating screw is here. Okay, and it is you can say that it is reciprocating means what? It will rotate and it will move in forward direction. Are you getting this? Reciprocating means it will rotate and it will move also in forward direction. In this way, it will apply the pressure, and due to that pressure, through this nozzle, it will enter in that mold cavity. This is our final part. Okay, how this final part, we are getting this final part. Okay, here I have highlighted this clamping. From this, it will be separated, and we can remove that. You can open that mold, and that part is ejected. Okay. Here, please try to understand injection and ejection. Injection means we are pushing this raw material into this cavity, and ejecting means that after cooling we will get the final product. That final product we are ejecting from the mold cavity. Injection and ejection. Ejection means removing. Okay. Here in injection, we are inserting the raw material or adding the raw material, and whichever product is found, that we are taking out from the mold cavity, or removal of the final product from the mold cavity is happening here. Okay, so this is the injection molding process, and we have discussed these steps. Okay, this is the clamping, injection, cooling, and ejection. Okay, in that working, you have to explain these 4 steps only. Then we have discussed the advantages. Okay, in this disadvantages, this injection molding process, we know that its initial setup cost and tooling cost, whichever tools are required or whichever die is required for that particular operation, it is very costly. And whenever we are going for the mass production, hence means quantity of that product is in larger amount, then and then only it will be economical. Okay, otherwise we cannot use it, because its initial tooling cost, or say whichever equipment or setup cost is there, it is very high. And these are the advantages. Okay, whichever processing time is there, it is very less. As processing time is less, your production rate will be more. Okay, depending on this processing time, we will get the higher production rates, and dimensional accuracy is also very high, and related to the wastage of material, loss of raw material is very less. Almost all material we are using carefully. Okay. Some applications, I have shown these applications of injection molding process. Recording is what it is showing. Pause and stop now. Okay, so these are some applications, different kinds of plastic chairs, these stools, then crate boxes are there. Okay, then these are the toys. A number of means different shape crates and boxes are there that can be manufactured with the help of this injection molding. Okay, now in this today's session, we are going to discuss this extrusion molding, and after completing this extrusion molding process, we will discuss one concept that is calendaring. Now, I think already you have studied in the manufacturing process subject how the extrusion process is conducted. Now, this extrusion process, it is very much similar. I will tell you one example. Like suppose whenever daily early in the morning when you wake up, you are using the paste, means for brushing your teeth. You are taking that paste out from that toothpaste. You are using that toothpaste. Okay, and that process is very much similar to the extrusion, taking out the paste from that whichever bottle is there. Okay, have you seen that? Whenever I'm just applying the pressure, and from that outlet, that paste will come out. That is nothing but the extrusion. Okay, got it. Now to understand it, what we are going to do to take that paste out, initially whichever raw material is there, we are going to melt it. If it is in very hard solid material, is it possible to take it out? If suppose that same paste I kept in the refrigerator or freezer at some negative temperature, and I am trying to apply the pressure, whether that paste will come out? No, it is not possible. So what is our first aim? Whichever material is there, raw material, it should be in the paste form. Okay, so that we can squeeze it out from one outlet, and at the outlet, as your that paste bottle is there, it is having round shape. It is having round shape. Whichever paste you are taking out, it will come in that round shape only. Are you getting this? Means depending on that outlet or opening shape, you will get the shape of your product. Suppose I want to manufacture hollow component. It is also possible with this extrusion. How it will be possible? Just you have to change that die. You have to change that die at the end corner. Just change the die, whichever shape you want. Suppose you want a square pipe. Put the die having square shape. You will get that square shape. If you want solid wire, then only round shape is necessary. Okay. So this extrusion is very much similar to that. Just keep in mind that example. You can explain it. Now some products I have highlighted here. For example, your window frames. Window frames are there. Then hose pipe. Then garden trellis, curtain tracks, adhesive tapes. All these you have seen. Okay, whichever products I have highlighted here, all these products you have seen. I think you are not knowing the names. I will show you the diagrams, then you will come to know. Okay. Now here I have explained the concept in short. Okay, in plastic extrusion, raw plastic material or resin beds are melted down. Okay, melted down, then filtered for uniform consistency and pushed through a die cut for the final product shape, and then it is cooled. Got it? Means initially what we are doing, we are taking the raw material, or it is also known as resin bed or beads, resin beads. Then it is melted down. Okay, we are providing the heat and we are converting it into the paste form. Then we are just checking that it should be uniform and consistent throughout. Whichever raw material is there, that mixture should be uniform. Okay, and then it is pushed through a die cut for the final product shape, and finally we are just cooling it. Okay, then we will get the end product. Now I will explain this with the help of a diagram. Okay, here just steps are explained. You can go through that. I will explain it with the help of diagram. Okay, this is the diagram, extrusion molding process. Okay. If you are finding it difficult, please draw this diagram. Draw this diagram. I'll wait for 1 minute here. Please complete it. extrusion operation is very much similar to squeezing of toothpaste from the tube. Okay, please remember this. So now we will start with the working principle. Okay, diagram is same. Just here this extra motor is shown, how this turning screw or rotating screw is operated. Okay, if it is not shown, then also diagram is correct. Okay, for your understanding, I have added this diagram, and I have added one diagram here, and it shows the further operations. Further operations, how means that final product is collected. Okay, how the cooling is done, then how the resizing is done, and how the finished product is obtained. Okay, this cycle you can easily observe in the industry. Okay, we are having one industrial visit in our syllabus. We will visit one plastic industry in our nearby area. Here this operation will be there. Then you will find that we have discussed this part only. And what they are doing here. Okay, they are doing the cooling. Then this is the, you can say in short word, resizing. Suppose you have manufactured the pipe, hollow pipe is there. Then after the cooling, sometimes some bending, slight bending may be there. So to make that pipe straight, then we are using this pull rollers. In short, you can say that resizing is done. Okay, or just size rectification is performed here, and at the end we are collecting it. Okay, we are not collecting that means without breaking, all pipes are not there. We are collecting it in pieces, some 10-meter piece, 5-meter piece, like that. Okay, for manufacturing of PVC pipes. Okay, PVC pipes are there, hollow pipes. That all PVC hollow pipes are manufactured with the help of this extrusion molding process. Okay, so one by one we will discuss this. Initially we will discuss the working principle, how it starts and how we will get the end product. Now this is the hopper. Okay, very much similar to the injection molding process. Now through this hopper you are pouring the raw material. It may be in the form of pellet or granules. Then it will go through this throat and it will enter in this barrel. Okay, this is the barrel. Now in this barrel, to provide the heat, we are having some heaters. Now just different name is used. Thermocouples, you can say that we are providing with the help of that thermocouple, or we are controlling the temperature. Okay, now this barrel is divided in these 3 zones. Okay, feed zone, melting zone, and melt pumping zone. Okay, feed zone, then melting zone, and melt pumping zone. In this feed zone, we will get the initial raw material. Okay, through this hopper and passing through the feed throat. Instead of writing just throat, you have to write here feed throat. Okay, then that raw material will be collected in this barrel, and in this feed zone, that whichever raw material is there is not heated up to the required temperature. Okay, then as it moves in forward direction, and how it will move in forward direction, now we are having this material here, but how it will move from this one corner to the another corner? With the help of this screw, with the help of that spinning screw or turning screw, and it is operated through one motor, or you can operate it by using any means. Okay, it will be rotated. It will be rotated, and as that screw rotates, okay, as that screw rotates, what it will do? Whichever raw material it will come, it will push towards that other end, or in forward direction, you can say that. Are you getting this? And what is the use of this spinning screw? Why we are using this spinning screw? Automatically, when we are pouring more material, automatically it will move in forward direction. Then why we are using that spinning screw only? Any reason? To mix it properly, to get the uniform mixture, you can say that. And why we are going to do the uniform mixing here? Because suppose we want some coloring to our final product. We want to manufacture some colored pipes, PVC pipes, suppose red color, white color, or black color pipe we want to manufacture. Then whichever colorants are required, that you can add in this hopper only, or through this hopper only. And whichever colorant, suppose you have added some additives also. Suppose you want to decrease the cost of the material, okay, or suppose you want to change the properties, okay, then according to your need you can add the additives. And suppose you want to change or give different colors, you can add the different colorants also. Then that part is done in this initial stage only. And to get the uniform mixture, we are using this spinning screw or turning screw, okay. And then which due to this spinning screw, step by step that raw material will move towards the other end of this barrel. Now here in the melting zone, due to the continuous heating of this barrel, or we are heating that barrel with the help of some heaters, that whichever raw material is there, it will start melting, okay, it will start melting. And due to that screw, whichever paste is formed, it will push to the other corner, or all the raw material will be collected at this opposite end, you can say, okay. All the raw material will be collected at this opposite end. And here at this opposite end, one filter screen and breaker plate is there, okay. We are using one filter screen and breaker plate, okay. Here whichever vertical portion is there, it will be here, this vertical plate. It will be here, this one, this corner. This will be your vertical plate. And what filter screen and breaker plate. What is the role of this breaker plate and this screen? Why we are using this filter screen? From name itself, you can understand its working. Filter screen means suppose by chance some extra material or particles are added in that raw material. Then due to that filter screen, that contamination is eliminated. And what is the role of this breaker plate? Now, before this breaker plate, your raw material, whichever paste is formed, it is in, you can say, the rotational motion. As screw is rotating, that material is also in the rotating motion. We are just changing the direction of that motion. From rotational, we are changing it to the longitudinal direction. And in the adapter, whichever paste is formed, it is collected. Okay, this is the adapter. Here, after filtering, your raw material in the form of some paste, it is collected. And at the end here, this is very important, the die opening will be provided. Okay, and depending on this die opening, you will get the final shape. Depending on this die opening, suppose this is the die opening, then whichever product is there, it will be in the form of wire. Okay, wire or rope shaped products will be there. If you provided here some hollow opening, then you will get the tubular component. Okay, and after getting whichever material you are getting or product at the end of this die here, okay, then it is subjected to the cooling operation. Then it is subjected to the cooling. This is the end of your process. But for doing some size rectification, we have added some operations, like we are using some pull rollers to do the size rectification, and we are performing some cutting operation to get the product in the desired size. Got this process? If you are having any difficulty, you can ask me. Okay, depending on this die opening only, you can get different shapes. Okay, just change the die opening, and depending on the shape of that die opening, you will get the different shapes. Suppose you want to manufacture this tube, then you have to provide some tubular opening. Okay, then if you want to manufacture some sheets or films, then single solid opening should be provided. Okay, and this is a very important operation. At the end, you have to perform the cooling, because it is having some, it is in the pasty form. Just we have changed the shape, and after cooling, that shape will become fine. Whichever shape is there, it will be fine. And during this cooling operation, we can use generally water is used. We can use any suitable cooling medium, but generally for this PVC pipes, we are using cold water only. Okay. Then depending on if suppose sometimes some bending of that PVC pipe may occur, to overcome from that bending of the pipes, these rollers are used. Okay, this is size rectification, and this is the collection. Here you can do the collection as per the requirement from the clients. Okay, suppose we are using some agricultural pipes, then you can manufacture long pipes. Suppose you have received the particular order, and it is very much used, going to be used in the for the household purpose, means your home. Then you can use the short size pipes also. Okay, depending on the need, you can take whatever dimensions and you can do the cutting operation here. Okay, so this is the extrusion molding process. Please add this part, whichever diagram you have drawn. You have drawn up to this point. You can draw these 3 parts. Please add this cooling and full roller. If you are having any difficulty, voice is not audible. Voice is audible. Please confirm it. I think my voice is clearly audible. It is not completely in the liquid state. I am repeating it again. I am using the word pasty form. We are not completely melting that plastic material. It is in semi-solid or paste form. Okay. And due to this, it is in the paste form. Just due to this die opening, we are giving it the desired shape, and we are performing the cooling operation. Immediately we are going to perform cooling. Then we will get the desired shape and size. We are not completely transforming that plastic material from solid to the liquid state. It will be in the paste form. Okay, you got it? Shubham. Nice. That is in the, I think that for metals we are doing it. Completely we are converting it in the molten state. But here we are converting the raw plastic material in the paste form, or very much similar to the, suppose you have used that bubble gum, like our gum. We are achieving that bubble gum. In the same form it will be there. Okay. We are not completely melting the plastic material. We are just changing it to the pasty form, or in the form of, you can say that bubble gum. I think I have mentioned that word in this slide. Okay, here the plastic is thoroughly mixed and has a consistency like thick bubble gum. Okay, we are not melting it. We are heating it, and the changing slight changes will be there in its form. You can say it will be in the semi-solid form. And that's why after completing, or after that material is coming out from this die opening, immediately cooling operation is performed. Please draw the remaining part. Okay. Okay, while completing your drawing, please listen some points I will explain here. Now, here, this part will be termed as the extruder. Okay, this is the extruder. Now, generally we are using two types of the extruders. I have highlighted this in the next slide. Okay, will you complete your diagram? I will explain it. Okay. Plasticizing extruder and melt extruder will be there. Then what is the difference between melt and plasticizing extruder? Okay, while drawing it, please try to understand this difference. Only melt extruder will be there. Whenever melt extruder is used, then it will just push the material, whichever raw material will be coming, it will just push it through the die opening. That is the melt extruder. And plasticizing extruder, it will change the form. Okay, it will change the form and then it will push. Whichever solid material is there, it will plasticize it and then it will push it. Okay, this way, that is the difference between the two types of the extruder, melt and plasticizing extruder. Then whichever shape we are going to obtain, that shape will only depend on this die opening, and this die opening is attached at the end of this barrel. Whichever barrel or cylinder we are using, at the end of this barrel or cylinder, this die opening will be there, and depending on its shape only, we will decide the, or we will get the shape of our final product or component. Okay, now there are three types of this extrusion process. Okay, that I have highlighted in this slide. Okay, depending on the product we are getting. You have completed that diagram. Okay, so I will move towards next slide. Finish. Okay. Already I have explained this plasticizing extruder. It plasticizes the solid plastic particle and then it pushes through the small opening or that orifice. Melt extruder, it only pushes the plastic paste. Okay. Then types of the extrusion, three types. Very simple. If we are getting solid bars or solid rods at the end, that will be termed as solid extrusion. Okay, solid shaped component. Then if we are getting hollow components, then it is hollow extrusion. And what is this co-extrusion? In this co-extrusion, what we are going to do, we will get the two products with the help of two openings. Okay, here we are using only one opening. Okay, simultaneously we can perform or use another extruder, and we will get the use the one opening and we will get one product from that opening also. Means at the same time we'll get the two products from two different openings, and before cooling it we are going to join it. Okay, after joining them or after performing one welding operation, then we are going to cool it. That will be termed as co-extrusion process. Are you getting this? This is one extrusion operation. What we are going to do in co-extrusion, we are going to perform two extrusion operations. From two die openings, we will get the two components, and before cooling it, we are joining them or we are performing one welding operation on them, and then we are performing the final cooling operation. That will be termed as co-extrusion. In this process, two or more extruded products coming out through the multi-opening dies are joined or welded together before cooling process. Okay, solid extrusion, hollow extrusion, and co-extrusion. So these are the three types depending on the product extrusion carried out. Okay. Now here one note I have added, that the thicker cross sections are extruded more slowly as more time is required for initial heating and subsequent cooling of the larger quantities of the material which are involved. Okay, means in short, if you are having thick cross sections, then it will be time consuming process, because time will be there for your initial heating and cooling of that component. Means processing time will be more. If thin component is there, processing time is less. If thick component is there, processing time will be more. Okay, and why that time is increasing? Because heating and cooling time both increases as thickness of the component increases. Okay, so these are some final applications of some products. Okay, insulating wires, which we are using in our electrical applications. These electrical wires are manufactured with the help of this extrusion process only. Then hollow pipes. It may be rectangular pipes or square pipes or hollow tubes, your PVC pipes. Okay, in different colors, you can manufacture them. Then these are your hose pipes. Okay, I think you are using this in the agriculture field or in gardens. Okay, or in farming, we are using this hose pipes. Have you seen these hose pipes? And then garden trellis. This is the plastic compound. These are nothing but your garden trellis. Okay. Why I'm showing these pictures? Because we know the name in Marathi language. That's why I have added these pictures, so that it is possible to remember it very easily. These are hose pipes. These are garden trellis. Garden trellis means plastic compound. Okay. Then window frame. Nowadays, these frames are made from the plastic material. Okay. Then adhesive tapes. Okay. So these are some applications of the extrusion molding process. Then these are the advantages and disadvantages. Now, advantage of this extrusion molding process, very much economical for mass production. When we are using this for mass production, it is economical. Then accurate measurements can be obtained, whichever dimensions are required for the end user, we can manufacture it accordingly. Then product with good surface finish can be obtained with the help of this extrusion molding process. Then design flexibility is there, and its lead time, or you can say that processing time, is very short or very small. Then disadvantage, it is not suitable for thermosetting plastic material. Why? Think on this point. Why it is not suitable for thermosetting plastic materials? Then whichever dyes we are using, wear of that dyes will occur, because continuously we are doing the extrusion process. Whichever raw material is there, pasty raw material is coming out from that dye opening. Automatically, due to the friction, material will be lost. Are you getting this point? Wear of the dye cavity, or whichever dye material we are using. Then you have to, close control is required, means whichever worker or operator should be there, it should be skilled. Then uniform cross sections can only be produced with a limited complexity of the parts. Okay, limited complexity of the parts means we cannot manufacture the complex shapes here. Complex shape we cannot manufacture here. You have to, whenever complex shape plastic products you want to manufacture for thermoplastic material, preferably we are going for injection molding process. Okay, here die opening, we cannot give the complicated die opening. Are you getting this point? Because whichever cross section shape means the die opening shape, depending on that, final product shape will be there. And for that, manufacturing die having complex openings or intricate shapes, it is not possible. Means limited shapes can be manufactured. Limited shapes can be manufactured in this extrusion molding process. These are advantages. Okay, advantages you can easily remember. This is suitable only for thermoplastic material, means for thermosetting material it is not suitable. Then as material is continuously coming out from that die opening, wear will be there. Okay, then complex shape we cannot manufacture it, and close control is required. Okay, in short you can write here, skilled workers or operators are required for this process. Okay, then we will move towards the next operation. This is calendaring operation. Please draw this diagram. I will wait for a few minutes here. If you are having any query, you can write that in the chat box. Please draw this diagram.
Girls Hostel College of Engineering, Pandharpur.
Okay. Okay. If you have completed your drawing, if you are having any query, you can ask me. Okay. Now I will complete this calendaring operation and I will stop this session. Okay. Now in this calendaring operation, Okay, but I will. Okay, now this is the calendaring operation. Okay, please concentrate here. So this is the calendaring operation. Okay, for performing this calendaring operation, basically we are using the rollers. Basically, we are using the rollers, and group of these rollers are termed as calendars. Whenever group is there, means that rollers are more than 2 in number, 2 or 3, 4, 5 like this. It will be termed as calendar. Now, basically, this calendaring operation is required. Suppose after extrusion process, you have formed the sheet of a particular material. Then that sheet will be converted into film. Means you want to basically change the thickness. Basically, I want to change the thickness of that sheet. Then I will perform the calendaring operation. And to perform this calendaring operation, whichever shape is used for the rollers, that is termed as calendar. And due to this, the operation is termed as calendaring. Whenever we are using 2 or more rollers to perform one operation, then that group is considered as calendar. And here we are using number of groups. Okay, and this operation is named as calendaring. Basically, it is performed after conduction of the extrusion process. After finishing extrusion process, suppose you want to change the thickness. Suppose whichever sheet you have manufactured, you want to convert it into film. Means very thin dimensions will be there. Then this calendaring operation will be used. And basically, this calendaring operation is used for thermoplastic material only. Okay, it is performed. Basically, we are performing it after completion of extrusion, and it is used for thermoplastic material. That you have to explain. And why the name is given as calendaring? Because we have used here number of rollers, and when 2 or more rollers are working together, then it is termed as calendar. Okay. Now here in this diagram, you can see that I have given different names: feed roller, nip roller, then tension rollers, then take up rollers. Okay. Then these names are given based on their functions. Okay. Initially, whichever sheet is manufactured at the end of the extrusion process, with the help of this feed roller, just we are feeding it. It will act as the feeder. That's why these rollers are considered as feed rollers. Okay, we are not performing the operation here. Just we are giving the direction to the raw material. That sheet is our raw material, and we are giving the direction with the help of these rollers. That's why these rollers are termed as feed rollers. Means they are feeding the raw material. And now the main operation is performed with the help of this nip rollers. In this nip roller, what we are doing here, basically we are changing the thickness. Whichever dimensions are required, that dimensions will be given with the help of this nip rollers. Got it? This nip rollers will help you to give the desired thickness. Okay. Then some with the help of this tension roller and take up roller, at the end, means just the function is we are collecting the final product, that take up roller. Okay. In the same way, I have explained that here at the end of extrusion, as we are collecting the final product, in the same way here also we are just collecting it. Okay. And in the tension roller, suppose some kind of stresses and that things are there that are eliminated here, and then it is given to the final rollers or that take up rollers to collect the whichever film is produced. It is rolled or it is collected with the help of this take up rollers. Okay. So this is the calendaring operation, and it is very much useful for this PVC material. Okay. If you are having any doubts, please ask me. And generally, please remember that this extrusion process, then calendaring, we are using them for the thermoplastic material only. Okay, when you are coming for the next session, please come with the answer why this is not suitable for thermosetting material. Very simple answer is there. Okay. If you are having any difficulty, you can ask me. Okay, whichever process I have explained, that is highlighted in different points here. Calendars are nothing but group of rows arranged in more than 2 numbers. Here 2 is there. And generally we are using 4-roll arrangement. Then it is an intermediate process where extruded plastic sections are reduced to the sheets. And here I have highlighted in green color, used for thermoplastic material only. Okay. Then what it involves? It involves rolling out a mass of prefixed plastic material, means the end product obtained from this extrusion process. Okay, with the help of large rollers, we are converting them into accurately sized films. Okay, and just extra point here is that whichever raw material we are taking, approximately it is at 100 degrees Celsius. Okay. Then they have highlighted the main roller is nip roller because it gives the thickness or dimensions. Okay, nip roller control the thickness of the sheet material and can be gradually reduced in the thickness. Okay, and basically it is used for this PVC material. Okay, in this way we have completed in today's session extrusion, molding process, and calendaring operation. Then thermoforming process and its types, then blow molding process. This we will discuss in the next session. Okay. So those who are attending through, those who are attending through online mode, please enter your roll number in the chat box for attendance purpose. Okay, just I will summarize today's session. In this today's session, we have completed extrusion molding process. In this extrusion molding process, we have discussed the various steps in extrusion molding process with the help of these diagrams. Okay. So this is the overall extrusion molding process, how it is conducted in the industry. Then types of the extruders used. We are using 2 types of the extruders, plasticizing extruder and melt extruder. Then types of the extrusion process, depending on the product extrusion carried out, as solid, hollow, and co-extrusion process. Then applications of extrusion process with their advantages and disadvantages. Then calendaring operation. In this calendaring operation, we have discussed what is the meaning of calendars, then how the actual calendaring process is conducted with the help of different rollers like feed roller, nip roller, tension roller, and take-up roller with its applications. Okay, generally with the help of this calendaring operation, whichever extrusion products are obtained, we are converting them in the films. Okay, so we have completed this part. I will stop this session here only. You can leave the session now. After this session, online session will be there. Those who are going to attend through online mode related to the project development and engineering. Okay. At 4 p.m. I will share your link. You can join it.